Hello guys, once again thank you for joining me in this discussion for our new topics here, which is the multiple motor load calculations and their overload protection device rated capacity. Okay, we have here four SCIM, multiple motor loads. SCIM means these are all single phase 240 squirrel cage induction motors. And we have here all this data here for this different inductor motors we have here. Okay, just take note of this. And these inductor motors are inside in this magnetic starter each. Okay, and they are individually installed in bus bar gutter, the main feeder lines. So they don't need any more the rating factors of the wire size because they are individually installed. Just take note of this. Okay, these are the PEC reference articles that I have applied and my basis for all my calculations. So you just have to take note of this so that you can be guided properly. Okay, these are calculation procedures I have here. You have the FLA here. Of course, this FLA are can be seen in the nameplate motors. Okay, so we have here all the nameplate motors, the FLA 29, 48, etc., and for the 78 motors, and the SF factor, service factor, is based on this PEC 430.32. So you have the given service factors there, and the FLC, of course, you also need to get this FLC and based on this PEC 430.14.2, and you have all this PEC here for the motors. And the branch circuit, of course, for the branch circuit here, you need to base this on the PEC 3, that's saying that 2.6B 16. Take note of this, that it's going to be a 75 degrees column and not 60 degrees or 90 degrees, because you have to default this because these are motors. Okay, and of course when you get this branch conductor, you need just to multiply this by 125 and you can have the size of this conductor size. And for the branch OCPD, you have to reference, you have to use this PEC 430.4.2, and this 4.2 will give you, if you are using this inverse time breaker, you need to multiply this by 250%. But if you're going to use the dual time element time delay, you're going to multiply this by 175 degrees. We have one of the motor which is using this DETD, the dual element time delay, and the rest are ITB, or the inverse time breaker. Alright, and the OCPD, of course, you have to base this on the 2.4016. These are the rating the fuses and the breakers. So you can just find it here. And of course, if you are going to use this SF factors, the overload protection device, based on the service factors times the FLA. So if you have this 1.3 service factor here, the rule here is that if it is more than 1.15 or above 1.15, this will be multiplied by 125% here, and you get this times the FLA, and you get this 36.25. and if this is okay, up 1.3, this is lower than 1.15, so you have to multiply this by 115% times the FLA, then you will get this 55. And if this is unmarked SF, then you have to multiply this by 115% times the FLA. And if there is no SF, unmarked SF, only this 40 degree temperature rise or below, you have to multiply this by 125 times the FLA, so you'll get this one. Okay, if we that is the maximum overload for capacity for your motors. Now, if you are going to find out for the main feeder line, you have to use this PEC 430.2.4, which is the highest FLC times 35% plus the sum of the motor FLCs, and you will have this. The highest FLC we have here is 50 amperes. So if you add this, you will get this 147.5 there. Okay. So you can use this based on you can use this 260 mm squared based on this PEC 75 column. So you have this 60 and use this TWG 30 mm for the GEC, and for the OCPD you need to refer this to PEC 4.35.2a, which is the largest OCPD. Our largest OCPD there is 150 amperes on these 4 motors, and the remaining FLCs, motor FLCs, so you'll get this 235, and based on this 240.6, you will use this 300 amps to 2-pole. It's an inverse time breaker. Okay, now we have a special case here for a Y delta motor starter. This is a 3-phase and not a single phase anymore. So this motor here will start in a Y delta, and in a couple of minutes it's going to shift to a delta operation. That's why they call it a Y delta starter start. So we have given here the line current of 60 amperes for the delta, and the safety factor of 1.3. So if you're going to get this phase current here, the delta, this is what we are going to intend to obtain this phase current for the delta, which is 60 amperes times 0.577, which is equals to 30.62. Where did we get this 0.577 or 57%? This was taken from this, or derived from this one, the delta, closed delta connection. We are going to take this phase current here, and that phase current is equals to this is I line current divided by the square root of 3. So that 1 over square root of 3 is the result of this 0.577. That is where we derive this 0.577 from this equation here. Now we have already taken this we have already calculated this 34.62. that is for the phase current of the delta, and we are going to take this maximum overload protection device of this delta, which is 125% times the phase current of that we have just calculated, 34.62, and this 125% was taken from this safety factor 1.3, which is more than 1.15. So we have this maximum overload protection device of 43.27. Take note that you cannot set your overload setting beyond this or over this 43.27%, but instead you have to go down from your calculated value. Okay folks, if you want to get updated with my upcoming technical videos, you're invited to subscribe and share to this to others. Keep safe from this COVID, folks. Thank you.